So as we move into this next section, my name is Patrick Brand. I'm a professor of political science here at UT Dallas in our School of Economic, Political, and Policy Sciences. That's what this EPS thing means for us. What I want to go over for kind of this next session is kind of the follow-on step. So when we started off and I looked at what Dr. Khan presented earlier in the week, there was a lot of discussion about how are we going to turn your unstructured data into something more structured. And so you've looked at how to extract all those features out of this. As you can see here, I've got a big disclaimer I've had to add to this with support from the National Science Foundation, as well as the project we're doing here now, and support from Exceed, which is NSF's Big Data Computing Initiative. We've put together a real-time event data system. That is, what we're doing is we're pulling in streams of news reports. We're processing those in the same way as you're getting instructed in how to do that here today. That's Dr. Khan and his students' expertise. My expertise is then on the other side, which is how do we then make that into something interpretable? So what we've done with this is we've created a set of event data streams and provided an event data API and server. And that's what I want to spend this afternoon showing you what we've done with that, what data resources we've made available, and then how to access that. Our access stream here is a little different. I see everyone else has been working mainly in Python from other things for what we're doing here. On the consumer side of this, what I do as a political scientist, we mainly train our students to work in R. And so the coding and the language stuff we've set up here, we've actually built an API that Saeed has got great examples. He can show you how to access it with Python. For me, looking at how the Python and all that comes together for it is completely non-intuitive as someone who regularly works in R. So the examples and the software we've put together for this do this in R. There's no reason you can't go back and forth between them in terms of doing this, but the examples we're going to have are set up that way. My student Zara Lodi's worked with me. Zara, put your hand up so they see you. Zara's here to help out with this. So we'll be there to help you out and kind of see how we do these basic things in R, but I know there's nothing we're doing there that can't be done in Python, right, Saeed? Saeed's nodding his head, because otherwise he's in trouble, right? Because he's the one who gave our students the help with the interface so we could build it to do it that way. So what do I mean by this? Well, we've got a couple things we want to cover here, right? The first is, what do we mean by event data? And in our case, it's going to be very specific to taking information from particular news reports that meet a particular pattern matching algorithm. So we're not going to be mining the data or using a topic model or something like that to go and discover the patterns. We have preordained patterns we care about. And this mainly comes from a research community in political science and international relations that over the nearly last 25 years has developed sets of pattern recognition software to look for particular kinds of political conflict and cooperation events. I'll touch on the software stream that we have for this and show you some of those things as we go through. But at first I'm going to start off and really spend our time diving into the specifics of what this political science, international relations, event data community actually does. So whatever questions you have about that from whatever background you're in, throw them at me. I'm part of a group we've created to do this. It's kind of a standard/socialization group for this called the Open Event Data Alliance. I'm one of the officers of the organization, so I'm happy to field any queries, and if for some reason I can't answer it, I can find the person who can in our group. That's our first part. The second is we've set this up in a framework where we have provided this together in one data stream. I already heard a couple people saying, oh, my computer crashed, I tried to do too much of this. This stuff gets to be big data computing real quick. Because even once you've filtered a small number of news reports to work with, given how noisy the news reports are relative to the volume of the signal you're looking for, you're processing a lot of data. And so one of the things we've realized is even when we do this and we're generating 3,000 to 4,000 new events in a real-time stream every day, making that data accessible for a regular user, that is an analyst or someone else who's supposed to be consuming and interpreting that data, gets tough. So what we wanted there was a simple way to get access to that. So we've built this event data server that includes both our real-time data as well as a number of historical event data sets that I'll talk about. We've been part of a bigger team of people that includes people at the University of Illinois, another group, or a group that's splintered off separately that got funded by the Department of Defense that's then made their data available. The problem is to work with any of these big data sets, you end up having to download them and hope that you have enough capacity on your existing computing environment to do this. We're trying to obviate that because we know at the end of the day, you know something about the subset of data that you want to dive into and query. And so what we're trying to do here is provide an API that gives you that sort of query engine that says, okay, I only want to work at this fraction because it involves this region of the world or this type of event or news from this kind of source. And we allow you to filter into that directly. So we want to look at how to do that. We've set this up in a way where you have to get an API key for access. So we basically want your email address so that when I go back later to the people I have to acknowledge here, I can tell them you exist, that I have a user community, right? You can put yourself down as whoever you are, but I need to know I have a user community somewhere so I can tell those nice people so they'll fund us further. But what we want to show you then is, okay, in this framework we've set up, and it turns out the framework's totally open source. So everything we've put together and shown here, we've deployed publicly on servers funded by the National Science Foundation, meaning you can copy our same thing we're doing and do it elsewhere. What's nice about this then is we can show you how to mine this. And we're going to show you a couple of things with this using R, and in particular an IDE for R called RStudio, which should be deployed on all the machines you have here. We're going to show you how to extract data from our real-time data and then actually learn some stuff about it. So we've built a particular package of functions here that do the subsetting and understand the variables in the different parts of the database. So I thank my colleague Vito DeRazio and some of his PhD students for doing this. We have a nice package and software vignette to do this, and I'll show you how that's documented. Then I want to show you how we actually present the data, which is kind of a step beyond some of what you were being shown in the earlier sessions with Kibana and the other things. Here it's down to that granular level of show people the data over time. It turns out event data have a lot of validity when we look at them over time and we see how much material conflict was there between ISIS and the Syrians in a particular point in time, right? And we can show that trend pattern and say it's going up or it's going down. So we'll look at that. We'll look at some other visualizations, including some mapping things. And really what we're doing here is leveraging the fact it's easy for me to get the data into R. And then with R, I get 13, 20, I don't know, I haven't counted the latest time, tens of thousands of packages for doing analysis and visualization. So I get to lean on the best of the statistics and data visualization world, and I don't have to come up with that tool. Right? I can lean on the best cutting edge stuff that's being done. I mean, one of these I was just looking at today that just was sent to me was a brand new package on doing mixture distribution modeling if you thought you had data from two different distributions. So think about one that's normal data and the other that's the anomaly data. And you're trying to separate out those two distributions. They had new methods for fitting models to do that and then visualizing the differences between this cluster and that cluster. And literally I could, off the shelf, if I wanted to, pull that, it's cutting edge research published last year, read the papers and implement it. So that's kind of one of the nice things we get out of this. You're not waiting along for, does it show up in SciPy or something else? So we'll do that, and then I'll show how to do a basic kind of simple parametric prediction model just to show, yeah, we can get this out of there and predict a trend in a particular situation. So these machine-coded political event data date back to a series of projects in the early to mid 1990s. And the main goal there was to take the unstructured news reports we might have and put them together in some sort of quantitative form that measured the level of aggregate overall conflict and cooperation between different nation-state actors or even subnational actors. Right? So this is very much in the wheelhouse of what is done in the intelligence community and by the Department of Defense. Initially, when this work was done, and from about 1995 through about 2012, anytime we went to do this, instead of the streaming, go crawl the web, go get the data resources that way, literally we would go to the data librarians at the university and say, will you please beg, borrow, and steal to let LexisNexis or Factiva let me download 10,000 news reports, right? And so you hope maybe someone would ignore the fact that there was copyright on all these things and that we'd be violating the download restrictions we'd have for our license and the rest of these things. And we'd hope to get enough of these news reports and then encode them. By the time we hit the middle 2000s, though, what became apparent was the real need and demand for this stuff was the streaming or the real-time data. And there were several groups of political scientists and other library science professionals who tried to start doing some of this. And the problem is, I don't know how to do it. Right? I'm trained as a political scientist. I'm trained in theories of measurement for international relations and modeling political data. I'm not trained to build real-time streaming systems like Lautefer and his students. So we tried to do this, and we kind of did okay at it till we got some grant money and partnered up. What we've been able to do since then is build this sort of real-time machine-coded event data set. What we're now doing, and I forgot the process slide in here, I'll have to add it in later, is every 20 minutes, we have a real-time server using the same kind of scraping, streaming technology you've been looking at here that goes out and crawls 380 websites globally. So we've kind of preordained a list of what we think are the relevant news sources to get good coverage. Right? So we've chosen local news sources where available or necessary to cover certain regions. That data is then brought back. We parse all those sentences, as you saw how to do on Monday with a Stanford Core NLP algorithm. We then feed those through a software that looks for certain subject, verb, and object patterns. So who does or says what to whom. And that's what encodes our event data information. That's put into a set of categories that are part of what's known as the conflict analysis and mediation observations or ontology. The O varies sometimes depending on the usage. We'll discuss what that is, but this, unlike, say, organically discovering what are the topics or what are the anomalies we've defined up front, here's what we think are instances or examples of material cooperation. Here's examples of verbal cooperation or verbal conflict between nation states or different groups. What we've been able to do with this, and this is where it becomes this big data-ish thing where we then have to think about how do we provide access to this, is we've now encoded since October 2017 about 2 million real-time observations. Now what we've done then is we've taken this huge mass of unstructured information, of which only about 7 to 8% actually turn into these events, right? Meaning I have more than 20 times more this of news reports that I've parsed and done things with, right? And had to do all that parsing and all the computational work on that to generate this set of observations here. Now, regular people who have nice, powerful laptops and good computing environments can work with that. The problem I have is part of my constituent audience is not you. Part of my constituent audience is a graduate student at State University somewhere who has not unlimited computing resources available to them. Right? And we want to somehow make this data in a real format available to them via the web. The other one we've come across is we've helped people out as part of our research on this project and on related things, we've expanded this. So we know people, there happens to be a group at the University of Illinois, Urbana-Champaign, that has had a long time access to an entire full digital corpora of the New York Times from the end of World War II to the present. So you start thinking about, wait a minute, I want to go mine that corpora. That's great, except their restricted license doesn't allow me to go in and access the data. Meaning we've had to provide them with the software and walk them through how to work with it on their data because of the copyright restrictions they have to face on that. We faced a similar thing. One of our sets of partners at Oklahoma University managed to work out the world's most sweetheart license with LexisNexis. For some reason, they found the right data manager on the right weekend, and they got a really great deal. And so we got access to a large corpora of LexisNexis that covered basically from about 1979 to 2015. And we were able to process that. Now, we can't provide you the original source text, but we can provide you the derived structured data that we encoded from that. That's another huge data resource. I'll show you some other ones. The issue this creates is mere mortals working with PCs can't touch this stuff. So what we've tried to then do and put together is how do we have these APIs, how do we have these backends so that we can allow regular, I say regular, I'll put air quotes around what a regular analyst is going to be. Basically what I mean is someone with less than supercomputing capacity to actually get in here and work with this stuff. So this gives you the background on all these pieces. So our main page right now, our main landing point is eventdata.utdallas.edu. We'll hopefully get to put this through a test here. The API query format that was originally put together for this was done by Saeed, who's lectured you earlier on this. Now, here's the great thing. So we're sitting in our regular research meetings, and he comes back and says, well, here's our queries, right? We've written the API, and the API basically says, okay, provide this, provide the field. You have an API key that I'll show you how to sign up for, right? So this is basically your login to get access to it. And then you have to know the data fields. And we have these specified out, right? So the source is who initiated the action, right? And they can have so these are ones that represent North Korea. So notice we're using like an ISO style code to represent the country names. Here we want actions that involve public statements by the United States on a particular date. So again, we feed in this part. Here's the target. Here's the root code. So I got to know the variable names, and I have to know the date code for this. So we can build for you an API document that shows you how to do all this. And we've done that, right? That's the link I showed you on the earlier slide. And you see this goes on further down the page here with other examples. Here's my problem. My problem for the researcher, right? So notice this one now we've had to pass in, we want a regular expression for France because someone can't remember the ISO code for France. It's FRA, by the way. Not like it was a tough one to remember. So this format is not hard to do if you understand APIs and you're probably somewhat proficient at Python to generate what these are. This doesn't work for me trying to train Zara and the next generation of my social science students who I'm trying to get good graduate degrees so they can come work with your peers, right? I need something that's more user-friendly for this. And so that's part of what we're going to be looking at here is how do I make this more user-friendly in what I'm trying to do for this. So that's where we're headed here. We basically have done this. My recently graduated student, Kate Kim, wrote for us an R package that does this. We'll see how to install this and work with it. We actually just published a paper in the Journal of Open Source Software that covers how to use it, right? So this is one of these like, yeah, I can spend my time figuring out the Python, or I can invest in how do I use this R package. What I want to do is walk through how to do this and what we get back from this. So I'm abstracting away. I don't care so much about the stuff about the unstructured data. I'm happy to talk about how we get from the unstructured data through to the derived, and I'm going to walk you through how we do that. But what I really care about by the end of this is can you get at the derived or the structured data we've produced from this and be able to do things with it to feed into other workflows or to advise others with. Okay, so that's our first part, is defining out what I meant by the event data and where actually I'm potentially headed with it. So our key thing next then is to see how these pieces actually come together and how we're actually producing what is this. This is kind of my main goal for this first part, is to have you understand how we've gotten to this. I'm happy to talk about places we get this right and places we get this wrong and ways we may improve this, et cetera. Believe me, I'm part of a pretty active community in this area right now. So we're starting off where our event data are in this particular format. Who does or says something to whom, right? So the who part becomes my source or the subject. Here's the verb part I'm trying to parse out of the sentence. And here's the target, right? The what and to whom. So if you think of, Iran, bombed a ship in the Strait of Hormuz, you get what the source and the target are there, and you go, that's a form of material conflict, right? Somebody makes a denouncement, that's a verbal attack, right? Or verbal conflict that may be going on. So the who part for English is actually pretty easy. Turns out we've tried to expand this and do it for Spanish, and it goes horribly wrong when we do it for Spanish, right? Just because of the different construct of the language, you very often don't have a declarative subject in the sentence. And so you're having to go back from the conjugations of the verbs and everything else and the co-referencing and actually determine what was the subject of the sentence. You have the same with objects and co-referencing there as well. And I'll show examples of this, right? We categorize this based on this conflict analysis and mediation event ontology that was developed by Misty Gerner and Phil Schroet back when they were at the University of Kansas, and then continued by Schroet when he was at Penn State. He's now a private consultant. But they basically came up with this very detailed ontology that really I'm going to show you, we care about 5 main categories: neutral comments or neutral statements, verbal conflict, verbal cooperation, material conflict, material cooperation. The to whom, same issues as finding the source. Where turns out to be way harder than I ever thought it was. Humans have this incredible ability to disambiguate geography that is immensely hard to teach a computer how to do. We've spent some time working with different tools here on how to do this, and trying to build on some earlier ones that were developed at MIT with MIDI and some of its extensions, Clave and Cliff, which is what we're using now. We've also built some new ones as part of our team, trying to use things like the Elasticsearch algorithms you saw the other day with pre-trained geographies to try and use that to learn where events happen. Laudifer and his students have built yet another version of this piece of software called Profile that we've used in some extensive experiments. What's interesting about these data, and this is where the modeling part comes in and what I think is the interesting part at the end, this easily fits our definition of big data. It's multivariate, it's hierarchical, it's spatial, it's temporal, it's also sparse. Very often, I may know the source, I may know the action, I may not know the target. The target may go unspecified. Or maybe I have really good pattern example matches for the source, the action, the target, but getting the geography is tough because the only geographic information I have in this New York Times news report is outside Mosul. And for operational reasons, the news report is not going to tell you which direction outside of Mosul things were going on. I mean, we may be able to infer it based on other things, but it may not be within the context of the article to recover that information. So it turns out for decades and decades and decades, the way we dealt with these problems in political science, in many ways still do, for, say, the militarized interstate dispute data set. They've tried machine learning for that. It doesn't work. This is our main international relations data set that tracks conflict and cooperation between nation states. Right? So they've tried deploying the techniques you've been learning here. It doesn't work. They've tried crowdsourcing. It doesn't work. Because the events are so rare and require such specialized detailed knowledge to actually report the details of them, it's very hard to get a human to do this. So humans can parse this and come to some level of agreement. The other one, and we've done much less work on this than we should in our project, is humans easily and rationally dispose of duplicate information in a way that it's really hard to get a computer to do. I saw one of the examples in one of Saeed's slides, I think from Monday, where you had said something of someone was buying a ticket or someone was arranging to travel, and those are basically the same conceptual thing.
Booking a hotel.
Sorry, what was it?
It was booking a hotel and arranging for lodging.
Booking a hotel and arranging for lodging. Where a human is, that's the same thing, right? But trying to get the computer to understand that is much, much harder, so it's harder to get at that. The other one we found in the course of this is we have, depending on the news sources we pick, a lot of effort trying to get source validity on this. That is knowing which streams of news reports we actually should believe. This shouldn't serve us as a difficult problem in 2019 to realize we might have an issue there. And it becomes one for us here is I can whitelist a list of 300 some sources, right? That means I have to still ensure I'm getting those 300 some sources, right? The feeds don't break down, the links don't break down, right? The IP addresses or something don't change in what I'm doing. The other is when we go to look for patterns in this stuff, right? So we're actually at the point of, we've taken what was the unstructured data, turned it into the structured, and now I'm looking at the derived structured data. The human thing there is to put a pattern on it, right? So a lot of people have spent time on this and shown we tend to put narratives when really it's just chaos and random. And so we've got to be careful of that here, despite having thrown all this computational machinery at everything, it gets tough. Here's my geography example. We put this in a paper we published a couple years ago when Secretary Kerry was actually Secretary Kerry. Secretary Kerry, speaking from Paris, denounced Vladimir Putin's support of Bashar al-Assad's government. Now let me tell you how the event coder is going to disambiguate this, right? This is a US actor speaking from Paris. The from Paris part is key here. Denounced, okay, so now we've got verbal conflict. What's being denounced? Putin's support. So this is Russian support, which is another action. The Russians are supporting Bashar al-Assad. That has to be disambiguated into Syria, right? And it's the Syrian government, so that modifies that. So our algorithms for the pattern recognition can do that based on past examples and things like that. What's difficult here is, what's the geography? It depends on what you care about, right? If it's the actual main event, which is the announcement, then it's a U.S. action towards the other, right? So then the geography actually would be Washington, despite Secretary Kerry speaking from Paris. Again, you see there's a rule that's got to be put in place here when we think about even something that simple for this. So you can imagine my sense of what the geography should be as a political scientist differ quite a bit from, say, what my fellow computer scientists may say or pick.
Because even in this kind of situation, there are times where stuff gets said locally, but when you say it in theater, it becomes much more interesting.
Correct. And that's why I put this example up here, particularly for this audience, because I think it makes that point and it gets you to go back and think, oh, well, I could just run through this streaming data and grab everything that was a location, right? Grab everything the part of speech tagger told me was a location, pass that into another algorithm that says, find me the latitudes and longitudes of these events, right? You can do that. You can grab a gazetteer that will do that for you and say, oh, I provided back the lat longs. Well, no, you didn't, because now you've got to pick. Right, so this is even worse than the Paris problem, right? There's Paris, Texas, Paris, France, Paris, Ohio, Paris, Illinois. So this is way worse than that one. The great thing we've been able to do here, though, and this is part of what I want to share and part of why we have the API, is we figured out really quickly trying to do this for corpora of any significant size. Now, part of it, we've made the problem big because we decided to pick 380 news wires to track. You know, part of that is, well, that's just kind of what we were tasked to do in what we wanted for our project. But even if you make this a moderate size, I'm trying to think, Said, when we first started, we did what, about 50 to 100 news feeds? I know this is a long time ago. This would have been like 2.5, 3 years ago. Yeah, we did 50 to 100, and we rapidly outstripped the computing cluster in the building. You know. So, moderate size university computing cluster, we hit the wall pretty quickly, right? So that's why we ended up going to the National Science Foundation and their Exceed program, which, by the way, anybody can go into, right? Government, industry, for whatever purposes. So that's why it's nice as an illustration of it allows you to scale these problems. And so we've been able to go in there and actually, carry this out and do some of this. What matters here for us is the following. The data are highly variable, right? And at best we can get is we've built algorithms here that with speed and accuracy can get 70 to 80% accuracy, which if I had well-trained humans, that's about as much as I'm going to expect them to get for agreement anyway. So in that sense, we're doing pretty well. We're also going to face challenges in ontologies and actors because there's continuously new people arriving. The pattern matching system we have for detecting events relies on dictionaries. So it relies on, in English, we have a fixed set of dictionary patterns. They're a very robust set of patterns that classify out in our different forms of the Cameo ontology for verbal cooperation, verbal conflict, material cooperation, material conflict. That part's really well developed and pretty solid because there's been 25 years of humans coming up with what those patterns are and encoding them from different news reports. And there's kind of only so many ways we can say stuff in English, right? We've then translated that over and done the same thing in Spanish. And what we thought was going to be a relatively straightforward exercise has now turned into 2 years of quite interesting research. Saeed's back there nodding his head. He knows. He helped out a lot with that. We've also done the same with Arabic, right? So one of our inferential goals from this project was to show that the methodology we have here travels, and that we can carry it across key languages. We are only working with modern standard Arabic. Is that fair? Yep. So yes, it limits our news sources, but if you look at most of the news sources in Arabic, that's what the news is reported in. So in that sense, we're okay, right? You're right. It's not going to work with signals intelligence coming from various dialects of Arabic. We got a problem there, but that's not my world. I'm in the news report world. But it turns out detecting new actors is tough. We've had to build a tool for this. Let me show off a little bit here since I can pop back and forth between these things. Here we go. So we've actually built a tool that goes to contemporaneous news reports for us and suggests, based on who's reported in various news reports, who would be a possible new actor for me to include. Right? So Brexit's clearly not an actor. Yeah, it's a wrong one. So that one gets eliminated. And then it suggests new ones to me. And you see this goes on for me. So we've got a learning algorithm that goes out, combs through our news reports, and says, hey, who are the newbies out there who I didn't already know about? And so, you get political change going on in different places, and you see, this one is probably, the difference there is the accent on that A. I probably have Nicolas Maduro in our data, but the accent is, we haven't probably caught those cases that do that. So we've had to build tools to do things like this to keep up on our dictionary patterns, right? So that gets at our ontology piece. We've solved part of the volume problem. That is, we can encode that many reports per day. We can do this many. Actually, the software for doing the encoding does that in seconds. So that's not the problem for us. The problem is having to go through a huge volume of news reports and do all that parsing that you were shown how to do Monday and Tuesday, right? That's computationally intensive. And so what we've set up, very much using Spark and Kafka and the other tools you saw today, is a distributed environment to do these different steps for us, because they're contemporaneously happening, right? We're streaming in new data, we're having to detect actors, we're having to code events, we're having to store those data back off in our data storage so that we can access it in real time. And this is our key competition here. My goal on this is I don't want to wait around for the next iteration of one of the great international relations data sets, which may only get done every 5th year. That doesn't advance my research. It doesn't advance my interests in wanting to analyze data in real time. So I don't care about months or years, which is what I get for these main academic data sets. I want to see stuff and do it in real time. So I want to be able to say, hey, was there a run-up in, say, Iranian events in the Gulf region prior to them attacking the British ships? And I want to be able to go back and look at my data, or be able to be looking at my data and say, hey, there's a weird pattern here. Oh, look what's coming. And do those sorts of things. So I care about velocity a lot. So there's other versions of this out there, and I'll show you some of these, right? There's the Integrated Crisis Event Early Warning System data, which is a project that's now being run by Lockheed Martin that originally was funded by DARPA. And that's great if you're one of the insiders to the project or know the people who are the insiders to the project. I also know there's a lot of walls around that project. So part of what we've been trying to do here, and kind of the background on this is we're calling what we're doing the Open Event Data Alliance. We're trying to keep this stuff as open and available as possible for other people to expand it and use it in a way that Lockheed Martin has no interest in doing, as you can understand. So we've got a lot of pieces in this, most of which you'll know, right? So we've got our standard we're going to do NLP on our events, right? So we're going to use Stanford Core NLP as one option. So when we do this in English, we're going to use that and get constituency parses of the main sentences in our news reports. It turns out and this is something to experiment with, you don't have to usually parse the entire news report to get the main event. And the proof of this, I always tell people, is on your way to the airport when you're flying home, get a print copy of the New York Times. Just read the first 3 paragraphs of every article. So read paragraph 1, paragraph 2, paragraph 3, stop. Go to the next article. Do that all the way through. Then ask yourself when you go into work and you're talking to your peers, are you any less informed than you'd been if you'd read the whole thing? And it turns out most of that information is buried in there because that's how journalists are taught to write. So we're able to use that to parse this. Now, we can use NLP for English and several other languages. The problem is, how do I make that parse so that my coder can understand it when I go from language 1 to language 2? What I need there is a different kinds of parse. I need not a constituency parse, I need a dependency parse. So for this trick, when we do our stuff in Spanish, which I'm not going to present today, we use a different parser called Universal Dependency Pipe, or UD Pipe, that does this. From that, we feed this into our other software. So our initial version of this is Petrarch. So my colleague Phil Schroet started this out originally with some of his colleagues. And it encodes the political text in the conflict analysis and mediation event observations using this. So what Petric is, and if you haven't caught on, we have a convention in our research group of you have to have an acronym for everything, right? So Petric actually stands for something. It's the Python extraction for text resolution and related coding hierarchies. This predates several other pieces of software we have. So the ones that are ours tend to have acronyms that actually spell something out. So we've extended this then from here, which was mainly developed to do English, using the output from the Stanford Core NLP, and we've then implemented it to use the output of the universal dependency part. So this extension here is going to allow us eventually to produce our events in other languages, assuming we build the dictionaries. Now, we've done some automated tools for building those to move from English to Spanish and English to Arabic, and to populate back the other way, by the way. So we've got frameworks for doing that moving forward. We should probably be able to start deploying Spanish here in the next X months, and I'm not going to tell you what X is. Sorry, because I don't have a good estimate of it. So how are we working with this, and what are we doing with it? So we've got a handful of pieces. Touchy HDMI cable. So we've got a handful of pieces here. So we're doing some of the things you've already seen how to do here. That is, we're scraping news reports and building a pretty sizable database of these things. Now remember, we're only getting a yield of about 7 to 8% events per news report we're scraping, meaning I'm sitting on a huge corpora of scraped events that don't generate anything under my ontology, that are there ready for us to mine and do other things with, which are the kind of the things you've been doing here in some of the other sessions. We've gone back and parsed those lead sentences, usually the first 5 to 7. Use that information out of the parse to get the source, right? So now I'm going to go for the main subject noun, the verb for the action, and the target, right? And then we co-locate or change and map actual names and verbs back into our dictionary ontology. So basically what? We have a whole bunch of lookups that go on inside the software, right? I detect a verb. The verb is in a particular class of material or verbal verbs. Then they're either in a class of conflict or cooperation. We map into those for one of these Cameo categories, right? And what we're going to look at, we're mainly going to see examples of these or top level ones. So it turns out the most common category of what goes on in news reports is just comments, right? Someone says, oh, it's really great you British have elected a new prime minister, right? So what do you get? You get a whole bunch of interactions right now. The French reach out and congratulate Boris Johnson on being chosen prime minister, and the Germans reach out, and the French reach out, and the Finnish reach out. And so you get a whole bunch of news reports like that, right? We saw something happened, right? And we acknowledge that something's happened out there. The other ones are the verbal and material conflict and cooperation. So if we have two states or groups A and B, right? This is what I refer to the, group A, disparages group B. I don't like you, right? I don't like you. I don't like your relatives. I don't like your family, et cetera. We can think of different classes of that. My Secretary Kerry example is a good one of those from earlier. Verbal cooperation are basically, some positive interaction that's totally spoken or is part of a written communique or something like that. The more interesting ones are the material conflict and cooperation, and I always give the extremes on these, right? The one is I shot weapons at you, right? And you can imagine even that is an escalatory thing in the conflict analysis and mediation event ontology, right? Low-level arms are kind of a low score, and then we move along, and kind of the end out here is like thermonuclear war, which never happens, right? But we have these rare events that go all the way out to, like, say, mass atrocity events out there. And then our nicest form of material cooperation, we'll sell you a weapon, right? Because we really trust you. We figure you're not going to use it on us, et cetera. The last part of this then is to go back. Once we know A and B and something about the verb structure of the sentence, then we can engage in this geoparsing exercise. And we've made some efforts in this, right? So our colleague Andy Halterman up at MIT has developed a piece of software called Mordecai. I'll show you the links into this stuff in our Open Event Data GitHub site. We're actually building on top of some software that originally came out of MIT, which then morphed into Cliff and Cleveland.
Where are we demonstrating
it depends. This protest is like the hardest thing in the world to do, right? Because in English, we have so many different ways to express the idea of a protest or a demonstration. And then we have modifiers we put around them for whether they're only verbal or whether they're violent. There's actually a whole group running out of Koch University in Turkey right now that's been trying to entice us to work with them on this. They're trying to do this problem cross-lingually, where you would have multiple streams of news reports coming in multiple languages, and you're trying to detect protest events across the multiple streams. So you can imagine, given what I already know about this problem in English, like I'm not real willing to jump on the multilingual version. It very much there depends on where and how you've classified the verbs and the adjectives around it. So what you'd think of as what we hope is a nonviolent protest is coming in here, right? Whereas once it has violence to it, it should be coming in here. That's in theory. In practice, actually doing that and filtering those cases out is much, much harder. I went through at one point at a conference, we were talking about different protest events around the world, and I was there with scholars who study cross-national protest events, and this came up, and they were arguing about the relative number of protests or reports of protests in country A versus B versus C. And one of the people in the room happened to be a foremost expert on protests in the OECD. And so while they were sitting there dickering, because they're mainly qualitative scholars, dickering about which country has more protests versus the other one, I actually went into our data like this and pulled 20 years worth of the mentions of protests across news reports in every OECD country and plotted them out over time. And I said, well, you guys can argue all you want. I put up a giant slide, and literally there was a time series for every country. And so I said, well, you're an expert in this country, and you're an expert in that country, and you're an expert in this one. So I asked them, I said, well, which ones are relatively right and relatively wrong? And that was the rest of the meeting. But at least they were arguing about data then. But I get it. You're right. There's a very tough classification problem there. And I'm happy to talk more about it outside of this. Okay. So here's what we're getting out for this. So imagine we're doing this for thousands and thousands and tens of thousands of sentences, every hour, right? So here's one we've coded out, right? So here's the main sentence. Right, so British Prime Minister Cameron on Friday announced the country would provide resettlement to thousands of Syrian refugees in response to the worrying migrant crisis. Here's the dependency parse for this. All right, so you can read the sentence all the way down through here and see that. And you see over here, here's the classifications, right? So these are all proper nouns. These are the main noun subjects for the sentence, right? So there's your source. Down here is the verb. You've made an announcement. Right, so we classify everything that comes off that. We get other information about the mood, the tense of the verb. Right, so it's, he announced, it's past tense. So you've truncated that or stemmed it. And then we get to the objects come down in here after the provision. So this actually coded into two events because we'd also get the one about the Syrians fleeing. All right, so that codes into our ontology. The parser comes back and says, okay, there's two events here. Right, it's a British government towards the Syrian refugees, and they're making an announcement, so that's a 010 event in the ontology. Then it's Great Britain against a generic set of refugees, and their reactions, and so that's a 031 event in the ontology. So you can go look in the ontology, and it has all the different categories, and those are separate ones in how that comes together. So once we get that, we then want to say, okay, well, what happens if I start extracting that? Because, right, it's easy to generalize this and say, I have my 100,000, 200,000 million news articles, right? I run them through this predefined classifier, right? It's a deterministic classifier in what's there. There's no learning going on. There's nothing else. We've just said, these are patterns we're willing to classify. Here's our possible subjects. Here's our possible objects. Here's the verb patterns we're willing to entertain, right? So in that sense, it's very naive. Right, and clearly we need ways to get beyond this, and I'm actually exploring those with some other political scientists. We're like, why should I have to do this and predefine the 200 some categories? Right? What if they change over time? What if the ones we came up with 25 years ago aren't any good today? There's lots of examples of that. So in the course of doing this, when they first put together the bombing ontology part of this, it just was bombings. And so remember, they're doing this. It's 1995 when they're first 94, 95 when they're first putting this together. So the second intifada hasn't happened, right? So what we know is characteristics of that, you get a lot more suicide bombings. And by perception, we view suicide bombings as a distinct category of attacks from non-suicide bombings. And so basically things had to be revised, things had to be changed in the wake of that. And so this approach doesn't really allow for that as easily. So once we do this here, right, and this is from an earlier example of data that's not in what we're releasing, we went back and had events from 2014 to 2016. So this was an earlier real-time data set we were producing that's since gone defunct, but the example holds anyway. And we went through for that period of time and counted up, well, how many different kinds of events were there, right? So this is how many comments. So these are the main 20 Cameo categories. Here, there's subcategories, right? So that 031 I had is actually one of this form of verbal cooperation. That 010 is actually in this category here, right? So we truncate the last number to move from one categorization to the other. So, the most common thing are the comments, right? Then we have these categories of verbal cooperation, material cooperation. So you see those are relatively low. What do we have most? We have conflict, particularly high level, right? Verbal conflict in here. And then here's the main, most atrocity-based material conflict events. Those are down here. And we've plotted out those interactions there between the Syrians and ISIS, ISIS and Syria. So this is mainly the peak period of when ISIS is taking over territory in the contested regions of Syria and Iraq, right? And so you see, you've got a whole lot of this going on. And then this period here, right, the ISIS-Syrian actions basically begin to drop off very rapidly because this is when the Russians come in, right? And so we're able to see that pattern of, hey, there's this uptick in Russian-ISIS interaction, which is basically there's an intervention that goes on, and then things trail off after that. So we can go back and subject this to statistical analysis or machine learning or something else to look at those patterns. The point is the data have this kind of rough face validity that we can then use in subsequent forms of analysis. So as I've said, we've got a fair software environment for putting this together, and I'll show you some of this, right? Our main thing and our main page is our open event data. That's kind of our landing, like, what do we have? What are we about? What are our resources overall? So we've set that up as kind of an umbrella organization for what we're doing, not as any kind of clearinghouse or anything to say this data set's better than that data set or anything like that, but just say, here's what's available and what we find to be legitimate and what's going on in this community. We've got several versions of the event data coding software on a GitHub page. We've got the different versions of the data location. And then my big thing here I want to show you is how to access and work with the different data we've put together. So the one thing we've been able to do, and this is one of these I always say, yay, thank the taxpayer, is, instead of all of us going out at separate universities and doing research by buying separate resources to do all our computation and stuff, the National Science Foundation has come out and made these resources available for academia, for industry, for government, to do this kind of big data stuff. So it's like, yeah, you can go and rent your time from AWS, and your employers may be doing that already. But there's other things available that provide a fair level of support. And one of these is the NSF Exceed program, and our entree to it here in Texas, which is the Texas Academic Computing Center, or TAC. What they've been able to provide us to do is the resources so that we can create a big data warehouse that's doing two things. One is it's generating this real-time data and storing it for us, right? So it's doing this continuously. So this is the part, like, I know how to do, I can do to here. Actually, I can do all of it. The problem is if I want to do this and I want to do it for tens of thousands of news reports every 20 minutes. I don't know how to build that system. I'm a computer scientist, right? I know how to do the analysis of this stuff. I know how to define out the ontologies. I don't know how to make this thing work reliably so that it always does its job for me every time I ask it to do its job, right? That's why we've partnered and done this stuff with computer scientists to do this and put it together, so we bring our domain knowledge to what they're able to provide in terms of systems engineering and the rest of it. What that's let us do then is on this site be able to provide that data and the computing resources for someone to analyze and access those data, both the processing, bring them in, but then also serving them back out so that I don't have to store those millions and millions of complex observations from my derived data in a structured format on each computer I'm working on or in a given cluster, and I don't have to do it redundantly. The other thing it's let us do, though, because we have access to these big data computing resources, is I don't just have to give you this 2 million observations. I can go out to every other event data project that's out there, and I'm going to walk you through what these are, and I can make their data available to you. Meaning, I can go out, and this should be updated. I know that's not the right number. It's 17, 18. Yeah, Zara's knowing. She's looking at that going, that needs. So the Integrated Crisis Event Early Warning System was originally sponsored by DARPA and DoD, morphed into a project that was run by Lockheed Martin. They've produced this data and made available to a select community of academics and government clients and consumers over time. The academic community for it's always stayed small because it's been people who are part of the IQ's group. And the issue was, it was always said, well, it would be released for academic use at some point. And we went ahead and started our project and started doing this. And I kept saying, well, are we ever going to get IQs? Are we ever going to get IQs? And I told one of my colleagues at another university I expected it would show up someday when hell froze over. And one day I got a tweet that says, yes, hell has frozen over today. And they actually publicly made the data available. What's nice, though, is if you go to access this data now, it's stored on the Dataverse at Harvard. The Dataverse at Harvard is completely static. All it lets you do is download the data or analyze it in place. It doesn't allow you to subset it. It doesn't allow you to dig into it or dive into it or create anything you'd want out of it. We've solved that problem because we've put it in our data warehouse. So you want to think of each of these as a different table in our data warehouse. These Klein data sets come from the Klein Center for Democracy at the University of Illinois, and they happen to have built, as part of their collection, large corpora that include back copies and digital issues of the New York Times, the FBIS, the Foreign Bureau Information System, and the BBC Summary of World Broadcast that cover these large spans of time. We convinced them to go ahead and use the software environment I'm talking about here with Petrarch and the geolocation to actually encode their news reports. They've put these available on their website for download. Again, you have to download them all, you have to store them, you have to then read them into some other piece of software or database to actually query and access them and do stuff with them. We've put them in as data tables in our API so you have direct access to them. Lastly, as part of our NSF-funded project, we've put together another data set that's derived from, this is the group that got the access to all the LexisNexis data. So they had access to hundreds of sources from LexisNexis. They did the same encoding on that. They called their data set they produced Terrier. Well, actually, I'll have the link to that here in a minute, so I don't need to be doing this. And so part of what we've been able to provide here then, in addition to generating the real time, this is one component of what we're doing. With our latest allocation from Exceed, we're able to support all these and access to them. So the benefit of our getting our API key and accessing the stuff is you're not having to go out and derive and download all these data sets yourself. They're there and available to you in this. And we've standardized with the R package how to access them. Because it turns out, you tell a bunch of people, hey, we're going to make event data sets. People will do silly things like the dates in one data set. So I'm a time series expert. So dates are always a 4-digit year, a 2-digit month, and a 2-digit day. Yeah, I saw that. But then you get the person who decides, no, dates are going to be stored as a 4-digit year, a hyphen, a 2-digit month, a hyphen, and a 2-digit day. We've gone through and standardized all those access issues for you across these different data sources. We tried as much as we could when we talked to everybody, hey, if you're going to use our software, like the data format's kind of nice to keep the same, but they didn't. The other is IQs, instead of following the convention that we've used in most of these, which is we record country names by their ISO 3 categories because they're standardized and we know what they are. IQs decided not to do that. So instead of putting China in as CHN, it's spelled out China. So we've gone back through in the R package and standardized the query mechanism. Now that's good for 2 reasons. If you're like me and you never can remember the 3-letter ISO code for Bosnia. I didn't see a nod on that one. I didn't see a single, everyone's like, I could Google it. I know you could Google it. Huh? What? I think it's BSN or BSH. It's the Herzegovina part that everybody forgets. Yeah, see? It's one or the other, and I forget which. But the point is, you could just put in, if you forget, you could just put in Bosnia. So one thing we've done with the R package is try to work across these things so you're not sitting there having to remember those innate differences across them, because we recognize those and know what they are. And the fact that we've done enough work with these different data sets, we've gone through, and that's one of the big benefits of the R package going in. I thought about trying to tell them to do it in Python, and then I thought better of myself. Right? Because I know how much work it was to do in R, and even in R, we could leverage some things. Like, it turns out some political scientist wrote a code that matches and merges all the different possible names we could identify countries.
BIH.
It's BIH? Okay.
We're all lost.
Okay. But you think of, you could spell country names out, you could know the ISO 3 codes. There's also ISO 2 codes, which are even more obscure to remember. Then you get my favorite, which is, say you want to take one of these data sets and you want to merge it back to one of those static international relations human coded data sets. One of the most common used codings there to record country names is what's known as the CAL codes for the correlates of war. The CAL codes break down by region of the world. So North and Central America are all 100 something. South America's all 200 something. Europe's all 300 something. Africa's all 4, I think, if I'm remembering these right. We've standardized how to deal with all that in here if you need it, right? So we've made it basically you can interconnect this data warehouse to other ones. Happy to share any of the back end of how we did this, because I know looking at the curriculum you've got going on here for some of the things you're doing, you would have similar problems and tasks to what we've done and worked with here in what you might be doing with this. So here's the data we're storing in the data warehouse. The first is the integrated crisis early warning system. So this is, it's weird. It's a crazy name for what's, because you would never name a data set that. But the project, because it was producing data, they just kept the project name on the data. And those of us in the academic community know what is that. Basically what it is Zara put down here, it's this integrated, automated system to monitor and assess this, but it's mainly data, and it's available there in the Dataverse. And they regularly provide updates until when they forget not to provide updates, and then with all of us who use this data gripe about it on Twitter, and then the data mythically show up someday. So it's nice because it's this standardized data. It covers from about 1995 to the present-ish, whenever they update it. But it's not real time. And so at least what we have is able to gap that in, and we've been doing some comparisons to that. The second thing was we worked with the Klein Center at Illinois. And as I said, they had these 3 main sets of holdings there as part of their archive. Now the problem with this is, to be able to get access to this in research and have this digitally, they've had to sign agreements with the New York Times, the BBC, and FBIS to not release the source text, meaning they can't make it searchable online for anyone. You can go into their secure computing environment and query it, analyze it, run your machine learning algorithms on it, whatever you want, but you literally have to go into their lab room, which is maybe like 8 of these machines, to do your data and do your stuff. By at least doing it this way, we've unleashed out from them, with the event data coding, some structured representation of, hey, what do international relations events look like in the New York Times over this period of time, right? Or what do they look like in the BBC, right? So now you can think about, both from our real-time data and from this, right? You have multiple sources and streams coming in. Is there stream bias? Are there stream differences and things like that? And so we've got a literature that's starting to look into those sorts of questions then as well. I mean, so this is why I was almost chuckling when I saw the examples they put together for you. Like, we're gonna go scrape the Guardian. I'm like, okay, that's nice you're gonna scrape the Guardian, but you know, the political scientist in me goes, you're scraping the Guardian. So the last one, and this again, you know this has to come out of our research team because we have an acronym that actually means something. So the Temporally Extended Regular Reproducible International Event Records, or TERRIER, which is at terrierdata.org, which is actually housed on the Open Science Foundation site, is basically a giant event data news source coded from LexisNexis from 1979 to about 2015. So if you think about it, we're gapping on our existing software and stuff with the real-time stuff from about 2016 forward. We've got a big long stream of these pieces there. This ends up encoding about 76 million observations on about 30 variables. So this is kind of straining the limits of what you can get a powerful PC to do, right? Let alone trying to do any real analysis of it. Now we're thinking about cores and streams and processes and MapReduce and all those fun tools and things like that for basic data analysis. So having APIs that get into this without me having to pull down all 76 million observations becomes really useful. Because if we're growing this stuff at the rate of 3,000 to 4,000 more observations a day, I'm building bigger and bigger data streams. And I'm sure what's going to happen here as more people start to use this, they're going to say, I don't like the data streams you're tracking. Can you track some other ones for me? Right? And we're going to end up expanding and changing data streams or adapting those for our applications. So what are we mainly collecting? So these are the main sort of variables we're getting back out of our coder, right? So we are actually, and we've had to really fight with people to do this, like put an event identifier on it so we know they're unique and that we can trace them back to the news source. I'll show you that here in a minute, how we do that. So we get the dates in my nice date format. We then split them out. And the reason why we do this, and I argued with my database people and my co-PIs on this project, the reason we kept these as separate variables is so I don't have to waste the time actually ever parsing that date. Meaning if I only want dates in certain years, I have a direct way to read what those are off the cases without having to do another computational step. We record information about the source actor, so where do they match in the dictionary, which country are they matched to, which kind of agent are they within the government, that is, are they a legislator, are they an executive branch, are they a judicial branch type person. We do the same for the target actors. We record the conflict analysis and mediation event ontology code, the 2-digit root codes that go with those, what we call the quad or the pentaclass that go with these. Years ago, somebody took the conflict analysis and mediation event ontology and its predecessor, the World Event Interaction Survey, and mapped them, instead of being categorical codes, mapped them into interval codes. This was work done by Joshua Goldstein and his colleague Rising. So for some reason, we've kept these scores along. Please don't use them. I do this to make my fellow political scientists happy who want this. I say don't use them. Basically, if you just correlate the event categories, you'll get it. For the geolocations, we get latitude, longitudes, and place names. If we can, a country or an administrative name, right? So this is as much as what we can possibly extract from that. Very often, this is very sparse for the geography piece. That's still kind of what I'd call an active area of research in what we're doing on this. And then we get the actual event tracking here, right? So from our unique identifier, we have a database ID for the event, the original URL, and the whitelist. We are storing the source text. The problem is the source text is mine, because under copyright, I have it for fair use. I can't then open it for somebody else. So this is one of the big intellectual property areas that comes in this area of research is when you've scraped your corpora for your use, it's welcome and fair to be used that way. The trick is when you try and move it outside of your research group or organization and whatever's covered under that, it gets really tricky. So even I face the same problem that the Klein Center in Illinois faces in the course of doing this. So this is what the eventual database entries look like. So here I've just got them as kind of a tab or space separated piece. Now the original piece that comes back from the queries to the API that Saeed set up, this comes back in JSON. And in my case, it's kind of silly that it comes back in JSON because it's fully structured, right? The whole point of having JSON is for when you're dealing with non-structured or semi-structured data, right? So in my case, that's not really useful. This, however, I can read this directly into any piece of statistical software or database program for ready analysis there and for mapping and things like that. So let me show you some examples of this before we get into actually accessing the data. So this is from an earlier iteration. So this is part of the work that Phil Schroet did originally on this, which became the computational event data system. So this is a long-running stream of data he had put together. I've aggregated it up to monthly. But this basically tracks the Israeli-Palestinian conflict. So the M are for ones that are material interactions between the Israelis and Palestinians. And then here's their verbal ones. And I've taken a net measure. So basically I've subtracted one from the other. So negative values are more conflict, positive values are more cooperation. When I show this to experts in the conflict, they're able to look in here and say, hey, you have a big spike in conflict and cooperation here, right? That's the first intifada. This one clearly is the second one. When we've done time series analysis of this and we've correlated it back to, say, measures of Israeli public opinion, you find what you'd expect, which is as Israeli support for the peace process goes up, conflict goes down, right? So we actually get structural models we're able to build out of this stuff. We're able to take the derived event data and match it up to other outside variables and make different forms of interest or make forecasts with them, right? One of the ways we got that paper published was actually showing that when we include the public opinion measures, we actually get better forecasts of the path of the Israeli-Palestinian conflict than if we don't. Right, so one thing that comes out of this is it can feed into other kind of workflow streams and work with other data pretty nicely. Here's another one. This is part of an analysis we've been trying to finish for too long on Chinese and Taiwanese interactions in the cross straits, right? So this data I've derived out from the IQ's data set because they happen to have really good coverage of Asia because they zeroed in on a lot of Asian news reports and sources to build that data set. And they also have a lot from Latin America. And so we're able to track this over time and basically see how much conflict and cooperation. So this is a crisis point in 2005. If you remember this, this is when we messed up and landed a plane, or we shouldn't have landed a plane. We had an American plane go down, and it went down in China. It wasn't supposed to be there. And so that kind of tracks in on that crisis point. Our big thing here, and it's not relevant, you don't see it with this, but we've actually tracked this in against a bunch of mainland to the islands trade data. And the example of that I give is if you have an iPhone, right? The iPhone is the greatest example of trade between Taiwan and mainland China you could ever think of. Because technically the company that builds the iPhone is on Taiwan, yet they do all the work on the mainland. So tracking those trade flows back and forth between the two actually tells you a lot about the state of the conflict and about where these go. So that kind of gets through my basic description in terms of what we've built in terms of data and the rest of this. What I have from here out is basically a series of examples of showing you kind of how to work through this. So I mentioned we're going to do this in R. R? Okay, little-ish. Okay, that's good. That's fine. Zara's here. How many classes have you been in with me?
2, 3.
3, and they've all used R. And she helped me write all the examples for what's up in here. And the rest of it, she's also been helping in basically doing our side consulting for everyone who has questions about this. So what I want to do, some parts of this will look familiar, some won't. What we've done is we've set this up where you need to get an API key. And the reason why we've done this is we've built this Spark-based political event encoder, so yet another one of our examples. We've built spec on Spark. And this gets at our event data and provides this. So NSF lets us do this. We've asked NSF now each time, please allow us to have the computing resources to do this. So I write an application, I send it to the people at Exceed. They evaluate this. They say, hey, this is really great. The scientific and the other using community is using this. We really look forward to supporting it. We're up to, last time I checked, we were over, what, about 110 users, Saeed? You know, at various academic, governmental, industry institutions working with this. And that's great, and it shows we have user community. And what we're doing is we're giving you access to this MongoDB queries that are going to provide you back this in JSON format if you want to do it that way. Alternatively, we're going to do this and use the R package we have for it. What we're trying to get around is keeping you from having to store the updated data. Because when we first started doing this, the way this was done was a daily data set would be output. So we would generate a new data set on a given date. It would be put out, someone would have to download it, and you'd have to basically rebuild your database and data set to include the new events. So everyone was having to store a copy of this locally. Not good, right? They were having to update it every day. I'm willing to do that whole step for any user who wants to use our data. Whether you want to use it in Python, whether you want to use it in R, I don't care. Here's what I need. My coin of the realm is I need to track who you are. Not like literally, like I'm not Facebook tracking where you are, right? I'm tracking, I just need to know that you exist and that you use my data, right? Because then I can say to the funding agency, hey, we have these people out there, this is what justifies the computing power to do this. The computing power we're provided behind to do this over the last 3 years is basically providing resources in excess of, if I remember, $250,000 worth of computing resources, right? So me knowing who you are really helps out for the community trying to do this. So step one is we're going to look at API keys so that we can do this. We're going to subscribe that infrastructure. We're going to keep the data store. You don't have to. So if you want to update or change your query, you do it, you send it, you get data back. And we'll see examples of how to do that. What I like about it is I can show students when I do this how to reuse their code. So I can give one example. Here's how you pull data on conflict or region number 1 of the world. Somebody else can use that same thing, change the countries, pull data on region 2. And we give you access to multiple data stores and data sources. So here's our main piece for doing this. All right, so this is, as we're saying, we're not trying to provide any definitive imprimatur on any data sets, but basically saying, hey, here's what we've done out there, here's what the community does to look at this event data, right? Because the data that you're learning to derive and work with here, it looks just like what we're doing here. Your ontology, your categories are slightly different than what I have here, but you're generating the same sort of thing. When you take that unstructured text and you turn it into some structured or semi-structured object on the other side. So we've got our software listed up here at the top. That's the same thing that we're doing and providing here. All right, so here's the Petrarch software we were talking about. Here's the universal dependencies version. Here's where we're trying to extend our ontologies to different kinds of events. Here's the geolocation algorithm from Mordecai. And we go on and provide our other stuff. So you see here we've got our work in Arabic that we've done. The Spanish stuff should be, well, the Spanish stuff, because it's being deployed, is actually evaluated directly in here. So we've actually moved that into their full code base. So it doesn't sit separately like the Arabic does anymore. So we have that, and then as we say, we have these different data resources. And you look here, well, our main page says, okay, we're just going to point you out to the different data resources. Well, that's great, but if I have to go to terrierdata.org, now they want me to go, no, not there, it's on this page. Now I have to go through, there's the same variables. Here's the sources they have, and then I have to go through and download the same data from the Open Software Foundation. So again, I'm facing that same storage problem that everybody else has. So here's our first part to this. That is, how do we get the API key? So going back here, all right, so if I start on our original page, we go to data, here's where we're asking you to get that. All right, so the first step, this is kind of a good one to do here to start, and then we've got our break coming, right? So then everyone will have time for their API keys to show up. That, or we'll all be looking to Saeed and asking him why it doesn't work. You ready to be put on the spot? They're all going to ask for API keys at once. It's good. See, this is like the confidence. Like the political scientist in me has no confidence at all that when I do something involving the web or data, it's going to work, right? But let's try them out. Like I might as well see what my research assistant's been able to pay for, right? So names, email address. Like I'm not asking for much, right? So you can lie. You can give me your fake Gmail address because we all have that fake Gmail address that we use for stuff that we need an email address for. They need what?
They need the actual email address.
I know they need a real email address, but you don't have an extra Gmail address?
Do we have to tell you why we have one?
I didn't ask why. I didn't ask why. That's like I'm not going to ask you for your business card. I know better. Right? So put that in, get that, what you're doing. You want to access it, and tell me you're not a robot. Once you get that API key, right, you've got two possible options. So let me back up a page here, right? Right? I can come here and look at Saeed's instructions for how to format this, right? Which I take one look at this and I go, okay. If I only am going to do this once, that's great. If I need it reproducible and I have to teach a room of 40 people to do it, which is my regular thing, right? Because I teach 40 undergraduates at a time and I want to teach them how to do this. I need an easier way to do this. So I can do, right, a JSON type array like he shows here and set up these queries, right? Right, so there would be the base piece. You'd have to replace the IP address there with the actual URL. You'd have to put your API key in here. Then you have to put in your other query pieces. My other option, right, so coming back to my slide here, is I think outside of that. Right? So in my world, you may differ with me, and if you're welcome at this point to differ with me. If you're like, I can do the API query, I'm comfortable, then go for it. I'm not, because I know I'll mess it up. I'll leave a comma out somewhere. I'll put a brace somewhere wrong. You're nodding. Edwin's nodding with me. He knows. You've been there. Yeah. So here's my main audience. Right? Right? Yes, we can do it. We can do it Saeed's way. I'm not disagreeing with that. You're like, he's the power user. I am not the power user. Right? I'm this user, right? I'm trying to make a decision. I maybe work for an IGO. I need to get access to the data, whether it's the real time or the historical. I want to do quantitative work in this area, and I've been trained as a political scientist or an international relations scholar, meaning I've done standard social science training. I've probably learned Stata. I probably learned R, maybe a little SQL. Like the really cutting edge kids in political science now show up and know how to use Python. Right? But that's like the really cutting edge ones when I recruit them now. The R package facilitates this and basically lets me do these queries in a more natural language way of doing it. Okay, so let's get into this first tutorial, get it going, and then we'll be able to see some of the other ones. So we're doing this in RStudio. So RStudio is an IDE that builds on top of R. So if you're doing this yourself later, you need to install R, then you install a compatible version of RStudio on top of it, right? So that's one set of steps to keep straight. If you get RStudio, you're not getting R, right? They're two separate layers of things. So I always warn everyone of that if you're not a regular user. Then we want to go in and see, how do I put in the event data package? So this is very much like importing packages into Python. There's a mechanism for doing this in R. I'll show you what it looks like. Then we want to get at how to use the API key and how to input it so that it always knows what it is, because you're getting this giant hexadecimal thing and you're never going to remember it. And you're going to lose the email that it was sent to you in. Right? Because it's going to get buried so deep in that Gmail box, you're never going to find it again. And so we want to store that then as an environment variable and see how to access the basic data. So this next slide is basically reproducing what I have here in these scripts. So my suggestion here is for back here. So you're in this folder. You really just want to go ahead and grab all these files that are labeled .r scripts. Just zip them and pull them down in one folder. They don't need to access any other paths or anything else. We've written them so they're self-contained. So you can just put them in some folder, and they should work on their own in that folder. But it'll work better to do that than having to grab each one as we do each one individually. So RStudio then, when you open it, you won't have this open in here. If you go up It's always bad to point at the screen. You're always supposed to use the pointer. If you go up here, you get a file open dialog right off this little icon here. And then you'll be able to go navigate to your folder with that file in it. I'm going to start with this just tutorial 1, first one here. So a couple things about R, since for the uninitiated. Anything with a hash, any line with a hash is a comment. So this doesn't do anything. This can be run interactively, which is what we're going to do, or you can batch this entire file if you wanted to. So you could have a whole bunch of R scripts. Yeah. What's that? You're asking me for a bigger font. Sorry, I've been sitting in that seat when I've been here in the back, and I haven't been able to read a thing he's presented. Is that big enough? So anything preceded by a hash is a comment, right? So this is a comment. Here we're going to install this package. So we've got this on GitHub. So there's a dev tools package, which should be installed by default. It will then use this install GitHub package function. It goes out and reads this directory, and it will build the vignette. So what you can do to run this piece is highlight this. And then up here, you'll have a run button. So that run button will go out. Now you'll see it'll download this from the repository. It'll install that package, do a bunch of other steps, and it's going to build the vignette. What the vignette is basically the how-to for this entire package. And it also grabs any dependencies it needed. So you have a couple windows here. Here's your code. Here's your console. So here is your command prompt. Right? Your arrow right there, that active arrow is your command prompt. So like I can ask that here, do I have anything in my environment? That is, do I have any objects? And it says I have none. Up here on the right, and this is why you use RStudio, is you get a description of your environment. The environment's empty, which is why I have no objects loaded. It also gives me a history of what commands have I run. You see I was doing some other work earlier. I could save those. I could set them somewhere else. It also, if you wanted to pull in a data set from some other source, gives you automated tools to do that. Right? So you don't have to be an expert in how to read data in and out of R to get it in and out of R. The other piece it does is down here, you have another set of viewpoints where you can see, here's your folder for your Active Directory. Any plots you've had. So I have a historical plot sitting here we'll reproduce later. It lists off all the packages, and you see I have hundreds of them installed. The key thing here is the help. And the help gives you basics of R. And for what we're doing, what we care about are the reference help for the packages. So if I follow that, which I could either get from the packages list or from the help list, it lists off all the packages I have installed. And you'll find somewhere in your list this one for UTD event data. So I'm going to expand this up so it fills this. And we'll see here what we've provided is a whole bunch of functions to actually access the API. That is, what are the data tables on the event server? We can query what those are. We can get the entire extracted data of something if we want. We can get a query size. So if you think maybe you're going to ask the server for more data than it really can probably provide, or you think your query is going to time out, you can test it first. Right? So that lets you do that by checking the query size. We actually use that internally so we can tell you if your query is too big and you are going to crash things to stop you from doing things that will cause problems to us. We can get previews of those data. We're going to look with a couple of key functions here. One is one that's just going to pull data. So we're going to get a set of query elements. It's just going to go to the server and say, I want data from these countries or from this region, and it's going to pull it for us. And we'll get back all of those structured events that involve news reports. For that, we can do dyadic or source target combinations for those. We can restrict to times, and then we can do more complex queries, right? And so we can send an actual query. So we'll be able to write something that looks like a database query, but not have to write it in the API format with all the commas and the squiggles and the releases and everything else that have to go into that. So that's our real advantage here. So that's now installed. So once you have, I know this is going to be crazy. This is an R-only thing. So add-on things are called packages. So you'd be like, OK, I want to include the package. I should use a function called package. No, you use a function called library to load a package. So we use the library function here. And right, so that then has loaded that. You see there's no error or anything. And then we can get the vignette for it. Right? So what the vignette does is it's an addition to the help. And it basically provides a whole bunch of what I'm going to show you, which is a whole bunch of examples. So this package came together basically because I walked in one day and I saw Saeed's great API, and I'm like, that's really awesome. I don't know how to use it. Saeed put his head in his hands. It's not your fault, really. Really. And so I work with my colleague Vito DeRazio, who's written another interface for this stuff called Two Ravens for doing interactive data analysis. And so we've worked through that. He then reached out and we worked with our students, Kate Kim, who's now on a postdoc in Korea, Jared Looper, who's in law school at Michigan, and Mike Shoemate, who's visiting research staff at the Harvard Institute for Quantitative Social Science. So we got a good group of people to actually work on this and put it together for us, and the students have gone on to do good stuff. So it seems to work really well. What's nice in here is it documents everything. So you're going to see a lot of stuff here. Like this is reproducing that table that we had in the slides, right? So Zara did a good job copying the table. Thank you, Zara. But it details for you where our data are coming from. It links back to the sources for the original data if you're working with them. So you're like, OK, I need the citation of the IQ's data from the Dataverse. Fine, click on the link. It's there for you. It's also in the package, the way we've set it up. So this documents that, how to install it. So everything I'm walking through here is there. Vito, my colleague, is a big stickler on citations. And so we can always get back a citation for each one of the data sets that we're going to derive or download stuff. We've checked it out. It seems to work most places. And then we're going to walk you through how to do this. Basic search functions, how to find what the variables are in a given table, because they vary slightly from one to the next. And then how to preview and subset the data. So let's start with the basics of the API key and then take a break. That way everyone can get their API key. So here's mine. So you all now have an example of my API key. I probably need a new one for myself now. This is like the Dr. Brandt's tutorial API key now. Probably shouldn't use it for my own research. So here I say I want the data tables function, and it's going to return back for me that list of what are the data tables that we have in the server, right? So this list is going to match, right, the same ones we have here, right? So here we've got the various client databases, IQ's data, so there's the IQ's, the Phoenix real-time, that's this one, the client Phoebus, which is that one, and Terrier. So we've got the ability to access and query all those when I put in my API key. So you can imagine the first time I saw this, I said, that's great. I'm not typing or having to copy paste that API key every time. So we built a couple functionalities around that. One is just declare it as a variable. So we're going to call it a variable K. All right, so we use K, and then this is the assignment, so it's a caret and a hyphen. Right, so I've assigned that to K. So if I come down to the prompt, down here in the console, and I just type K, it gives me back my key. If I look in the environment, it's the only value I have in my environment right now. As if I ask for the data tables for that, so I just highlight that and run it, it gives me back the same list of the possible tables. There's a couple other ways to do this as well. We can store it as an environment variable. So there's a whole system environment that's here, kind of like a profile on a bash script. So we've now stored that as an environment variable. We can then check that and see if it's stored. And you'll see here in your list, here's all your R and RStudio variables. And down here at the end, we have the UTD API key, and it stored it there for us. So now I can call any function without having to put the key in. So that was the, I need users to have keys so I get credit for them later. I will note we do track for a given key how many queries you do, how big the queries are. We're doing that actually to help you out, because once we know things about the queries, we can optimize our database to give you back the queries faster. And so that's actually one of our next research goals, cross our fingers we get funded for it, is to actually optimize how those queries are all done, for different types of users. So that's our first example. So I've now gone on for an hour and a half. Zara's actually had to bring me more water, so that's not a good sign. Let's take a break. They brought the water back for us. That's always good. Let's take a break, and we'll come back and look at some of these other examples.